Okay, so hello. Today's contest that was weekly contest 247. One question arrived that is quite tricky and it involves string and bit masking. It is the third problem that is number of wonderful substrings. So today we are going to solve this problem and it involves some good tricks and really good for learning concept. I couldn't solve it in the contest, but when I looked up at the solution, it wasn't clear to me at first as well. I was doing something similar during the contest, but couldn't formulate the complete thing. So let's move on. The problem says number of wonderful substrings. A wonderful substring is a string where at most one letter appears an odd number of times. Okay, it is at most, so it can be like all the characters are appearing even number of times or any one of the character is appearing an odd number of times. So for example, you can check this. It only character C is appearing odd number of time, J is appearing even number of times, all the characters are appearing even number of times. So these are wonderful substrings. And AB is not a wonderful string because both of there are more than one character that are appearing odd number of time. So okay, so this given a word that consists of first 10 lowercase English letters, and now the problem states that it only involves the first 10, that is A to J lowercase English character. Return the number of wonderful or empty substring in a word, and we need to return that how many wonderful substrings are present. And substring, you should know, is a contiguous sequence of character. It is not a it is not subsequence, it is actually a subarray. If the same substring appear multiple times, then count each occurrence separately. So if um like uh, like here A and A appears again, so both of them are a wonderful substring, so they are counted separately. They will be counted twice. Now how do we solve this problem? How do we come up to this problem? If you look at if we think about the brute force solution, it's actually um, we will try to go to each and every letter and try to find, try to get all the possible subarrays and check in that subarray whether the frequency of the characters, all the characters frequency are even, or at most only one character is appearing odd number of time. So that will be taking the complexity of the brute force solution will be same as the number of subarrays that we can form out of a string. So if we check out its constraint is actually 10 to the power 5. So the number of subarrays you can think of are like 1, then 2 of length 2, and then of length 3. Then removing the first character, you can then take 2, and then removing the first two characters, you get just 1. So, or you could do it like in a backward fashion, just one length. When taking another character, it will form 1 and then 2 more, 2. Then this B, adding B will form of length 1, 2, and 3. So each character is going to add like one more length to the previous thing. So it will be like 1 plus 2 plus 3 plus 4. Okay, so the sum of all the natural numbers um, is the complexity. So actually, if you check out, it is 10 to the power 5, and the complexity would become a quadratic complexity, that is order of n square. So that would not solve, that would give us a TLE actually, because it will go to the 10 to the power 10, which is a very huge number, and it will not usually it's like 10 to the power 7. um, that should it should lie in the range of 10 to the power 7. So this will not work. Brute force. Another thing that we check is the words that exist are in lowercase characters forming A to J. So there are just 10 characters that can appear in a string. So usually in problems like these, where usually we should check a string, or a string problem usually have this characteristic that there can be only like 26 alphabets. So we can use something like bitmap, bitwise, or try like structure, where it's easy to check for all the characters rather than checking for all the possible subarrays or subsequences. So this problem also revolves around that. When I check the solution, firstly I would go with the like what I was how I was trying to approach it, but I got stuck, and then we will come to what was the actual solution to this problem. So if you want to skip to the actual solution, you can skip to that part, otherwise you may continue over here. So when I was trying to do, let me just connect my device. All right, so so what I was doing the problem was something trying to find odd and even of them, but it was kind of like not clear that how I should go. What I figured out, but something that if I have something like if I have some characters like let me just keep track of this thing. Yeah, if I have something like let's take the example that is given over here. It's A, B, and B. So it says that it can have just all characters are even, or just one character is odd. Okay, so what is the main thing that we see? How can I form? I was trying to come like if I have certain number of characters and I add a new character, I'm at this place right now. If so, oh, this time lag. Give me a minute. Yes, so we are back to this problem. Yes, so what happened is like if you are at some character and you are like trying to find like if I just add this character, how can I come to this thing? Like it says even or just one character as odd. So um if I add this thing like B character is added, and up till now I know I create some uh like that there'll be like 10 characters. So we can create something like this, all the characters where we will keep storing as we come to these characters. Okay, so if I come to this one, I will like 0 1 2 3 4 5 6, something like this. Okay, and when I come to this character, I will know that it is the 0th character, and so I will just update this. Then I come to this, it will update to 2. Then I will come to 1, that is no, then I will come to B, so I will update this bth character. I was considering actually these as A B C D E and up to J. Okay, so when I come, I do it 1 and then I do it 2. I was thinking this problem like this, but the main thing is, how do I make when I have B, what will be the solution if I know something about these? So when I add B, uh, to get the solution, either this or this, I will like all the characters before it, all the sub arrays that will go into the answer, they all should have even number of characters, and if B is present in somewhere over here, it should be odd number of time. Okay, this is one scenario. Now, and if we have to make this thing, then what we'll do? We have our B, and then there are some characters, and we want to make it as just one character odd with this. So everything else over here should be even. Even if B is present over here, it should be also even number of times. So everything over here should be even, or everything should be over here even except B. Okay, like this. um, so this is what I was thinking. So I thought like instead of storing what um, how should I do this, means it has to be something like dp, but how do, again it will be like finding all the subarrays and then getting the odd even thing in each subarray, that how many characters are odd and how many characters have to traverse this. So it kind of like I cannot get through like what should be the proper way to find it. So um, over here now we know these two scenarios now. So how can we use it? It felt to something like if we check this problem, it felt to like the if for all the characters, if even if we cover this array of all the frequencies for each character, it will be like 10 to power 10. These are 10 characters, so it will be like 10 to the times 10 to power 5, so it's like 10 to power 6 complexity, which is uh, which is all right. So now how can I just uh, figure out that what is going to solve this problem? So one more thing to check. So my two cases are that if adding a character, whatever the character is, let it be ch, rest all are even. And second thing is adding ch, rest all are even except ch. So these were my two cases where I thought I should work on this, but it was falling back to like how I will find if I add this character. How will I know that which part will have something like uh, which part is having all the characters even, means you can see that this part, let me just erase this, you can see that this part is actually all even. Okay. um so this can be the answer, AAB. And if we check this part, just erase it, if we check this part, this is odd number of times, so it will not help in B when we are at B. So we don't take this thing, but we take this thing. So this was confusing that how to arrange it. Okay. um Now to a problem like this, I need to find, let's be clear what needs to be found, what needs to be found, that is rest all should be even, or at least which character I'm having right now should be odd. That was my criteria. So I can use something like an array where I'm storing what is the frequency of each character. But the thing was that I didn't know the frequency at each cell value. Means when I'm at A, there has to be some frequency. Then when I'm at second A, there will be some other frequency, like some frequencies of all the character. Then I'm at this A, and there is some frequencies of all the characters. Okay, and when I'm at B, the frequency is changing. So uh, how will I know which frequency? In which case it's all zeros. Wait a second. Okay, so this is already mirrored. some things. Yeah. So these were some of the scenarios. How to solve it? What could be done? Like suppose I have something like let's take the same example. It is A, B, and B, and I try to find at each position what is the number of frequency at each. Let's store it like 10 arrays each time. Let us do that. I was thinking that way. So right now we know in this problem it's just A and B. So for simply fine, I am just using two arrays. Okay. Oh. Yeah. So let's just find and make it a two character array, and at each position I'm now storing that what is the frequency. Okay. So when I'm at A, I know it's this is A and this is B. It is frequency is 1 and B is 0, then it's 2 and B is 0, then B it's 1 and then it's 2 and this is also 2. So let us see what can we do over here, or what can we do over here. So over here it is um, because it is B, I want all those frequencies there except B. Like now I'm going with this thing. I mean I'm like now checking this. Okay, this is the first thing that I'm trying to do. So let's suppose that I'm at B, and because B I just ignore what is B. I want that everything else. If you see in both the cases, rest all has to be even in both the cases. So I don't care whether B is or sorry, B is or B is even. So I just go with all those cases where rest all are even. So I see that this is even, this is even. Yeah. So and if anything before this might be there in any of the cases, we'll consider that also. So in all those cases, I know B is going to work because B is the only thing that is odd. So I will include those results. So it will be 1, 2. So at B it will be like okay. Similarly, let's check what would happen for A. It's at A should be only the odd or even person, and rest all should be even. So if we check, everything else is even. So this is also even. So we can do as the answer. Then again, if I go to this position, everything else has to be even. So if you see everything else is even, I just add 1 over there. Okay. And then when I'm over this part, it's like B. We don't care what B is, but we care what rest of them should be. So these all three can be taken. So I will take these three. Okay. So this is 3, 5, 7, and 8. So answer is actually if answer is actually 9. Something we are missing over here, and that would be what? That is actually yeah. One thing is actually that is like in this last case. We didn't take this whole thing also. Yep. So actually, why we didn't take this? Because we see here it was mm, this is actually the sum of all the things. So it's already even, so we take 4 because it's actually 2 is coming from all of this. This 2 is coming from all of these structures, okay? Yeah. But yeah, it's not like this. It let's do it again. Yeah. So to oh sorry. Yes. So here we are 2 and 2. So now when I take at A, I know that when I have A, it is just adding 1. So this is going to be 1. Okay. When I'm at second A, it is adding, it is making even, and rest all are even. So I will consider all of these and also this. So it's like 2. It is 2. Okay, means all before it, that is 1, and only A is another. Then I am at this P location and I see that rest all are already even. So and this one is odd. So I can take it, and that makes 2, and means I oh no, why is battery low? Just charging. Give me a minute. Yes. So when I'm at B, I let's see what all will be working. It is like B will work always. It's one case. Then 2, it says that it's even, rest all are even. So everything is even up till now. So it means all this can be taken. Then I subtract this one from this, so it makes it a non-even number. So that will not work. So if I subtract this, it becomes this thing. So this is not the answer. Okay. So and then I subtract, so it's just b, and b is 1, so we can have it. So the answer for this is again 2. Okay, and for the last case, for the last case, yes, so I'm over here and it says 2, so it means whole this thing is included 1. Then I have to take consider this, so I subtract this part from this, it makes it odd, so this will not this will actually work. For a it will work, yeah, for a it will work. So you see that how we are just uh, getting lost with this kind of solution, because at when we were a, it wasn't, it might be forming some numbers, but when we are at b, uh, we just can't ignore b and find the answer for this thing, because in this case it's a which is the uh, odd one. So here's why it is failing. This solution is actually becoming complicated. Now we get an idea still that two things are possible. That is, rest all are even, then adding character b will make it as I mean will make b as the only character that is odd, and rest all are odd, so rest all are even and only ch is odd. Then um, it makes ch also, when we add ch, it makes ch also as the even, and all of them are even. So they are kind of, this was kind of like a vague thing that we can think of, but also one more important thing was this array of 10 characters. This also plays a role because it will help somewhere in reducing the complexity, but I was not able to come up with a solution that how to do this problem. So in the solutions, actually it's very uh, tricky way of solving it, but it makes the problem a very easy problem. So we are now going to discuss that, and it's actually like it's difficult to think that kind of problem. So let me just erase everything and this thing. So yeah, okay, so yeah, so the solution to the problem is, let me show you. I referred to this this explanation by Ed Antoine, and the step-by-step guide was not very clear, so I kind of not didn't check this much. Also, I checked this solution by Lee 215, and this one is pretty very in a nutshell it's explaining. So but it's actually a very like precise information given, so I couldn't be clear much at beginning, I also refer to this lecture that is by Larry.
Hey everybody, this
And in this lecture, it's actually explaining a good way. It's actually a good uh, way of explaining it. So, taking help of these, I'm just going to explain it in a more detailed manner. Now, this problem was tricky because to come up with such a solution was not easy for most of them. So, yeah. Now, if we have some string like AA, BB, all right, and in previous explanation, I was trying to like making array with each character, array of 10, array of 10 I was trying to make with each character, and trying to find in each of these character that what is the frequency. So better way to to symbolize the frequency, or you can say even oddness of characters, you can use something like binary representation, all right, where I could have, instead of an array of 10, I could have a binary number of 10. Okay, and 0 would mean as false, and 1 would means as true, means uh, 1 you can say as odd, and 0 you can say as even. Okay, so this is one thing. Second thing is that what is the solution to this problem, that is, let's just check out. So it says that um, the characters, all characters are even, or all characters even except one, except one character. Okay, so this the solution to this problem you can think of is when we are using this binary, and when we have to show something that all the characters are even, what will happen to this binary? If we have something like AA, or like AB, A, so if we represent A as 100 and B as 1, yes, and B as 1, 0 and 0, then this B, I will just update into the same, so this becomes 1, and then A becomes like 1 again. So this this becomes like even number of A's become. So we will sort this thing and make it as 0. Okay, so this will tell that in this whole character, B is only odd, A is even time, A is even, and this is some other character, that is C is even, that is 0 time. So we don't have to keep record that how many times it is even. means how many frequencies are there. We just only need to know that it is even or it is odd. Okay, so this binary representation help us how actually instead of storing these arrays that is over here, these arrays, instead of these arrays you can just make use of these. Yeah, let me just show you. So if I add a sorry if I add a b a suppose, and or let's just take the same example, a b and b, and I use an array to store the frequency. The frequency will be a and b, 0, 2 and 0, and this is 2 and 1, and this is 2 and 1. Okay, means in the same array I am just updating. And when I want to find the frequency of only this much, what I will do, I will just take this array and take this array and subtract this. From this it will become 2 minus 1 and 1 minus 0. It's actually 1 and 1. Is it? Oh, sorry, this is 2. So this will be 2 and this is 2. So it actually gives us the frequency of this. So it's like what you do in prefix sum and cumulative sum that you do to find out of a range. You just subtract the previous one from the cumulative. So this way, doing with an array is difficult because this will just increase your problem of just subtracting uh, each and every element of this array. This array will be of 10 digit long, so it will be like 10 operations to find the frequency of this range. Okay, so now if I try to do it with boolean number, suppose, let's just assume that instead of this so let's just assume instead of keeping these arrays, I am storing it in as a binary number. So what it will become, it will be 1 0 0. Let's just keep it short right now, just three digits. Actually it will be of 10 digits, but we can keep it short. So this, then second a will be like we just need to know, okay, like suppose just do it as something like we are actually storing the even and oddness. Okay, because after subtracting this from this, we were only checking whether it's whatever array we get, we were only checking that whether they were odd or even. So instead of that, we didn't care whether it was 3, whether it was 2, it was 1. We just care whether it is odd or even. So just because we are checking odd or even, we can use binaries. And when I encounter a again over here, I'm going to just XOR these this number. Okay, this number I'm going to XOR it into this. So this number is actually this number is actually 001. So when I will XOR these two numbers, it will become 000 over here. Similarly, this number is 010. I will XOR this number to this, it will become 010. This number is 010, I will XOR it with this and it will become 0 0 0. So this binary represent now when this binary representations come and I have to find for this range. Let me just change the color. I have to find for this range. Okay, what I will do, I have this current 0 0 0 and I have this thing, it is 0 0 1. I will XOR both of them and what I will get, I will get 1 0 0. So this tells that A is odd times and B is even time in this range. So this can be done in this single operation instead of instead of what we were doing with this array. So that's how a binary is solving a problem of decreasing the operation. So now one thing we have done, we now know that uh, that if we have some frequencies, uh, if we have these binary numbers, we can easily tell that and we are over here, we can easily tell that up till which number is it actually we have all of them as rest all except B are even. So what that will represent, it will represent when rest all of them are even, it will be all will be 0 except B. So it will be this. Okay, and similarly when we go to C character, it will be 0 0 1 0 0. Yeah, so this is what we we might be finding. Yeah, so when we are now, just let's recall what we were doing previously. Let me take a short break. Okay, so we are back, and yeah, so we were at like representing instead of the arrays, we are using binaries, and because in binary, finding whether it's like subtracting them is more easier than this array. So now let's see what we were trying to do. In the previous thing, what we were trying to do was when we were at some position, like suppose we were at B, and we have this array that is completely uh, even, like you can see it's all twos, it's filled with all twos. So we know that this whole array is in the answer. Okay, then we will check for reduced subarray, that is this much, and to get this we will subtract this and this. What we will get, we will get 1 and 2. So we see that it still follows a pattern, that is one of them is on the odd and rest all of them are even. So this also holds true and it becomes plus 1, that is it becomes 2. Then we reduce this subarray and we get to this subarray. Okay, we are keeping this B as common. And in this subarray, we'll check again, we'll subtract this from this from this, so it will become 0 and 2. Still everything is all even, so we will include this in our result and becomes 3. Then we change as a subarray and it becomes this much. Okay, so now for this it's just this subarray and it's all say, like what it will be. It's not this, it's like uh, this minus this, so we will get something like 0 and 1, which is again true because one is odd and one is even, so this becomes 4. So in this case, at this place we have 4. Similarly, we will go for when we were at this position, we will try all the subarrays, subtract and then get answer. But uh, for this also, if we see it's 2 1, it's correct. One will uh, we can have this as 1. Then like this array, it is 2 minus 1, it's 1 and then 1, so this will not hold, this will not work. Then we go to this array, and in this case it is a complete, so it's 2 1 and follows this pattern, so we include it and it will become 2. Okay, so for this thing we have 2. Then similarly we will go for this part. Now let's check. Firstly it is this part, so it's no, firstly it is this whole part, so it's 2 0 and it is all even, so 1 will definitely come. Then second thing we will shorten it, and this is 2 0 minus this, so it will become 1 0 and it also follows the pattern, so it will be 2. So for this case also we have 2. Then we will come to this part, means we will start from here, but I just try to show how it is doing. So I started from here, but we will start from this part. Now this is just 1 and it's 1 0 and as far as this pattern, so it is 1. Okay, sorry, this is 1. So the total will become 1 plus 2 is 3, 3 plus 2 is 5, and then 4 it's 9. So 9 ways are there. So now the concept becomes a bit clear that what will be the answer. This we did with array. Now let's try it with this binaries. So let me grab it. First of all, binary, it will become even more easier, and we will see something that will ultimately give us to what the final solution should actually means. It will be more optimized and more organized code we will see in this solution. Let's just remove this also. Okay, and on this thing I will keep it over here. Okay, now let's start from the right only, or we should start from this side. Let's start from right. I will bring this bit down so that I can write above. Now let's see. Let's start from this. So this value, that's 0 0 0, is actually of this complete. So we know that 0 0 0 means all are even time. So 1 is in it. Okay, then we reduce it. And to get this we will XOR this value with this value. It will give us 0 0 0 1. Okay, for this range. Now if you check this, it shows that only 1 is odd and all other are even. So this pattern is correct. and we will include plus 1, that is 2. Okay, so 2. Then we will change the subarray and it will become this much. In this case also, let's see, it will be 0 0 0 minus 0 0 0. It will remain 0 0 0. So it means all are even. So again we will add and it becomes 3. Then the last is just b, and for b it's like 0 0 0 minus 0 1 0. It will be 0 1 0. It also shows that there is just one character that is even. Okay, one character that is odd and rest all of them even, so we will add it and it will become 4. So for b it is 4. Okay, now let's move on to other part, that is this b. In this b it is 11010, so this whole thing is 010. It means there is just one character which is even, which is odd, so we add 1. Then we reduce this and we come to this much. It will be 010 minus 001. This will become 011. So in this case there are two of them odd which are odd, so it will not be included in answer. We go to next, that is just b, and b will be 010 minus 000. It will be 010, which is only single odd, so we will add and it will become 2. So for this we have 2. Okay, then let's move, and now we are over here 000. Let's take it. Then 0 minus 001, it will be also 1 odd, so 1 and it's 2. So this is also 2. Then let's come to just last case, and this is 001, this is also 1. So same again we are getting the same thing, and that is, okay, let me just reconnect. Sorry for this, it's not updated, it's not bought, so I'm just trying to use and show over an iPad. Okay, so we get the same answer, that is 9. Okay, so I hope you got it, but in this case also it is easily seen that this is not, this is still, we are going to each subarray, so it's like still same thing, that we have not reduced any complexity. It is still n square times. So now the actual optimization has to be done, because this thing could be achieved even through the brute force. So we haven't done anything really optimization in this. We have not done any optimization up till now. It's just that we have figured out some ways in which we can find the odd evenness in just order of one time. Okay, so let us just get rid of this. Yeah. So now the thing is to approach is bit tricky, because this thing to approach is difficult according to me, but it comes through practice. So what I'm trying to say is what we were doing when we were finding the for this thing, we were going through all the subarrays and we were subtracting the prefix sums and getting the answer. And one more observation over here is that the answer that after subtracting what we were getting was something like 0 0 0, it means all were even. Like when we were subtracting, suppose this is aj and this is ai, or let's take this is ai. So aj minus ai was something of this form. It shows that all are even. Or 0 1 0, it shows that only one is odd. Or 1 0 0 0 0 1, it just shows that it's only single is odd. Okay, similarly more, because it will be 10 digits, so similarly. So there will be at most, because there are just 10 alphabets, there will be just 10 of them. First, where all are even on subtracting ai aj minus ai. Then there will be 1 and this like 10, 1 0 0 0, then it will be at 1, then it will be at this position, it will this position. Similarly, these will be like from A to J, they will be 10, and this is the 11th position. Okay, so yeah, so now actually this will be, if we have 10 positions, just check this, because in most of solution it was 10 to the power 10 only. So it will 1 2 3 4 5 6 7 8 9 10, a b c d e f g h I and j. So at each position it will try 1 and rest all of them 0. There will be 10 ways to do it. Or if the answer is 0, means all are 0. Okay, so basically we are, at each time we are finding the difference, sorry, we are finding the difference, and if that difference is equal to any of these 11 patterns, we know that this adds, means this is the answer. Okay, so what else, instead of going to each uh, like subtraction, let's see what we can do over here. Like suppose I'm at some position and I subtract some value and I get 0 0 0. Okay, so um so it means this array or whatever sub array that has this thing. It also means that what we have subtracted are both identicals, means like this and this, means they both were identical, 0 0 1 1 0 0 1 1. Then only means we solved these two and then only we got something like this. We will get all zeros only when both of them were same. So instead of going through all, just for this case I am talking about, so instead of going through all the sub arrays, we can simply check if if this pattern has occurred anywhere up till now or not. And if it has occurred, it might have occurred at two places, it might have occurred at three places. Okay, it might be like 0 0 1 1. It might be at some more characters and then 0 0 1 1. So this whole thing will give us 0 0 0. This whole thing will give us 0 0 0. So so instead of going through all these subarrays, in this case we can just check that how many times does this value has occurred in our this prefix sum. That will be easy. We have to just maintain a count array. Okay, let me just show. We just have to maintain a count array, and in each array it will correspond to like 0, 1, 2, 3, 4, 5, 6, 7, 8, or in fact because it is 10 digits, it will be, because there are 10 places, it will be like at each place it can be 0, 1, so it is almost like 2 to the power 10. So there will be 2 to the power 10 ways, that is 10 to the power 1024 um, patterns could only be formed. So we can make this whole array of 1024 size and store, if we like this is going to be 3, so we just increment 3 as 1. If we find again, we just increment it to 2. So we know that like I am over here and not here, sorry, I am at some character, like I am over at this character, and I find something like 1 1. So I will check that how many times up till now have I found, sorry, this will become confusing, like a b b. I will check that how many, and I'm over here, then I will check, suppose this is 1 1, it's just as example, so don't take it as fact. It's suppose it's just 1 1, and then we will check in this whole array that where 1 1 has come. So instead of going through this whole array, I can just keep this count array and store it in this, that 1 1 has occurred at this position, has occurred 2 times up till now. So I will know that 2 times it's going to give me answer on the subtraction of wherever it has occurred. Okay, just let me plug in again. Hmm. So wherever at 2 times wherever it has occurred, I will know that it's going to give me this the XOR as 0000. So I don't need to go through all these subarrays. I can just find in this count array. It will take order of 1 time. So for this thing we have reduced. Can we reduce it for other patterns as well? Other patterns I mean, where it will be just one character odd. So 0 0 1 0 0 1 0 0 1 0 1 0 1 0 0 0, and like this. Means this will be 10 digits. Okay, so why are we doing this? Because these are the values that we are searching when we are doing the differences. This is one of our observation, that when we find the difference between these two, or these two, or these two, if the difference is something like what we just wrote, 1000 0100 0010, or 0001, if it lies in some of these, then it means uh, this thing is actually, then it means that this array, this, let me just erase some part. Yes, then it means that this if we subtract this and it falls in that range, then it means this part has just one character, that is the difference is actually what? The difference that we are finding is actually uh, telling us, the binary is telling us that even evens and odds, is it's telling us that. So, and if that even and odds fall under this category, then it means that range is our answer. Okay, that range is actually our wonderful subarray. Okay, this range. So we optimize for this thing, where that when the difference is 0 0 0, what we'll do, we'll just check whether, because 0 0 is not going to change our binary number, so we'll just check how many times this binary numbers has occurred up till now with the help of this count array. Okay, we will store that how many times it has occurred, something like this. For this we have optimized. Now we need to optimize for these. We will actually um, like actually we'll do, because these are just 10 of them, these are going to be just 10 of them, these all are going to be number of them, and these pattern are going to be 10, because at each position we are only just having single one, so there will be 10 of them, 10 ways. So we can, in each iteration, when we are like at this position, can just erase. So when we are at this position and it is some value, suppose it is something else, let's just suppose it is um, something like this, or not this, it is something like this, suppose it's this. So we will check what could it be. When we checked whether this number has occurred anywhere, we will be figuring out the ranges where it is this binary. To get whether it is 0 0 0 1, what we will do, we will manually subtract from this. We will subtract is actually zoring over here, so we will zor this number. Let's suppose it's something different. Yes, let us let's just change this number. It is, let it be 0, let it be 110, something like this. Okay, then what we will do, because we don't know where which number, which range, which prefix sum is going to give us this value, we will manually subtract this value. Okay, it becomes 1 1 and 0 0 1, and the XOR becomes 1 1 1. So it means if this number occurs at any of the prefix sum, uh, that is going to give us this value, this value. Yes, so we will search in this, that where does this number comes. So instead of searching this whole array again and again at each step, we will just store it in the ct count array. We will store whether that 111 comes one times or two times or three times. whatever times it comes, we'll just store it. So if it comes 3 times, it means those all the three positions are going to give us this value. Okay, so it's like just finding for all those, for doing this, we search for this value. So doing this same thing for all of these will be like 10 times, doing it 10 times. So at each character we are going to do 10 iterations, so it's like 10 to the power 6 ways of doing it. It will be actually at each position, it will be 10 to the power 6 ways. So what are the important things, that how did we reduce it? And like one thing is that there are just 11 possibilities. First thing is, of course, the binary representation. It reduced our complexity of finding the uh, odd and evenness in a range to a matter of order of one. Order of one, order of one, we can just find order even in range. Okay, then second thing that we come across is, second observation was finding that there are just 11 of the patterns which pattern of ranges that is included in our answer. Okay, so wherever the range value falls under these 10 of the patterns, those range values are included in our answer. So as many time as this occur, it will be into our answer. Okay, so okay, let's just connect it. Yeah, so next thing is, um, next important thing was, like, instead of going through all the ranges and I mean, um, it's like storing the value. We are using a count array to store the ranges valid, not valid actually we are subtracting the valid patterns and getting that some other pattern. That pattern if exists, then it means it is going to on zoring with our this current pattern, it's going to give us the valid pattern. So this is used to store the um, required binary, to store the required binary that when source gives the current binary. Okay, so these are main three observations, and the last observation is the hardest part because this actually reduces the complexity to overall just order of n. Okay, because we don't need to go through the whole array and find the differences. Instead, we are storing the the value of prefix sums that are coming. Each time we are storing the count of those prefix sums each time into our count array. Okay, and when we want some prefix sum, we just get it from the count array, that are how many times such a value comes, and we know we don't have to go through this whole array. Okay, so we don't have to do the uh, subtraction. Actually, we only need to find that that this number should be subtracted to get a valid pattern. These are the valid patterns, and these valid patterns can be obtained. These are just 10 of them, so we manually just loop through all the possible numbers that will give us this valid patterns. So let us try to now implement it. Okay, let me just close this thing. Okay, so yeah, so now this problem is reduced to it includes bit masking. It is including like the prefix sum. So these are the things which it includes, and it is optimizing it. So this problem was tricky, and coming up with these things is matter of practice. Let us just now compute what we did. So first of all, we need to have a count array. So we will just store this, create this count array, and because each count array is actually storing the prefix sum, means the count of each prefix sum it is coming. So the count of each prefix. So what is the range of the actually the range of the prefix sum? Because there are just 10 letters, it will be actually in 10 to uh, 2 to the power 10, that is 1024 values could only be formed. So we make this as 1024 and just initialize it with 0. Okay, and next thing is um, it is also doing one more thing, and that is okay, so let's go through all the words first of all, each character of the word. All right, and we have to return actually the number of wonderful subarrays. So NTNS is 0. Now the first one was this character is like just I'm trying to find the binary representation. So it's actually a number. So int a is equal to, let's just use bin, and it's actually whatever is this character. Okay, like if it is a, so if it is something as a, then how it will be represented in binary? I'm going to represent it like this. So it's actually 1 is shifted by 0. So let's just take C minus this, and then 1 is right shift by this value. Okay, so this is actually my binary representation. It's actually just a number, and then I will check in a CT that how many times does this binary occurs, and I will add it to my answer. If it's 0, it's not present. Okay, and then the rest of the patterns, that is, so this is actually for which pattern? This is actually for 0 0 0, means where all